Hi, everybody. So today we're going to talk about stoichiometry some more. And this is stoichiometry part 6. And so what's this all about? So we're going to continue with what we've already learned, and we're going to start with a little bit of review. And then we're going to move on into a series of problems, or a new type of problem that's going to really allow you to, I just triggered my Siri. Okay, so that's going to allow you to demonstrate that you really understood the material that we've learned, okay? So I'm going to go ahead and erase the header because I need the board space. And we're going to start with a familiar reaction. So methane combustion, which is of course important because methane is natural gas, which is used to power like our San Diego City buses, as well as the gas stoves and fireplaces in our homes, gas dryers, heaters, etc. Okay, so methane and oxygen combine to form carbon dioxide plus water. And the balanced equation gives us our stoichiometric ratios of molecules to molecules or moles to moles. So for instance, if we start out with 2 moles or 2 molecules of CH4, we're going to ultimately produce 2 moles or molecules of CO2, and then 2 times 1 gives us 4 moles or molecules of H2O. And we've also thought a lot about masses, and so we use our understanding of atomic mass and molar mass to convert from grams of one chemical to grams of another chemical. For instance, if we have 64 grams of CH4, we want to know, or we might want to know how many grams of CO2 we would get, right? And you might immediately think, well, there's 1 molecule of CO2 per molecule of CH4, and that's true. So then wouldn't you get 64 grams of each? But that's not true. So let's take a look at how we actually do this calculation. And again, this should all be review for us because we studied all of this last week. So if you start with 64 grams of CH4, you can then convert to moles of CH4. So you can multiply by 1 mole CH4 per 16 grams of CH4. And that's going to give you 4 moles of CH4. So now we've converted from grams of CH4 to moles of CH4. Okay. And then after we've got moles of CH4, we can convert to moles of H2O. So we see that there's 1 mole of CH4 per 2 moles of H2O. So we multiply. We say 4 moles of CH4 times 2 moles H2O per 1 mole CH4. And then we can neatly cancel. And then we can wind up with 8 moles of H2O. Okay. And so that's what we wind up with, 8 moles of H2O. And I'm going to go ahead and move to the last piece, which is to convert to grams of H2O. All right, so now that we've converted from moles of moles of CH4 to moles of H2O, we want to convert to grams of H2O. So how do we do that? We multiply 8 moles of H2O times, okay, 8 moles of H2O. God, that's an ugly H. Yeah, I'll just redraw that whole water molecule. So H2O times 18 grams H2O per 1 mole of H2O. So the moles of H2O cancel out. And we ultimately wind up with 8 times 18. So that's 64 plus 80, which is 144. So 144 grams of H2O. Okay, and that's our final answer there. That's how many grams of H2O we get from 64 grams of methane. All right, so I'm going to erase everything except those 2 numbers. I'm going to go through a quicker way to do the calculation. We can do this whole calculation on 1 line, and this is a really good way for a lot of us because it's shorter. And so if we start with 64 grams of CH4, I'll just rewrite that in smaller print. So 64 grams of CH4 times 1 mole CH4 per, I'll do a little better job with that 4 there. That's pretty bad. 1 mole CH4 per 16 grams CH4. Then I multiply by 2 moles. So now I've canceled out the grams of CH4. And ultimately, I want to get to grams of H2O. So I've got moles of CH4. I have to cancel those out, and I have to get to moles of H2O. So 2 moles of H2O per 1 mole CH4. Cancel that out. Then times 18 grams of H2O per, it's an 8, 18 grams of H2O per um, 1 mole of H2O. Okay, then the moles of H2O cancel out, and I wind up with grams of H2O as my final unit. All right, so if we do the math, we get 64 divided by 16, that's 4, times 2 is 8. 8 times 18 is 144. So we wind up with our same answer as before, 144 grams of H2O. All right, so that should be a pretty familiar process for all of us at this point. So if that was confusing for you, then you definitely want to stop by for office hours or chat with your group members right now to get caught up, okay? And I should be coming by to check in with all the groups to make sure that this is solid for us. But judging by our quiz results from our little mini quiz results from last week, everybody should be in good shape here. So I'm going to go ahead and erase this bottom part, and we're going to look at a slightly different problem. So let's stick with CH4, and let's say that let's just stick with the same amount of CH4. So we got 64 grams of CH4, right? And then at that point, we want to ask ourselves maybe, well, how many grams of oxygen are going to combust with that many grams of CH4? So this is a problem that you ought to be able to do on your own at this point, just by looking at the molar ratios. So you've got 64 grams of CH4. You can convert that to moles of CH4. Then you can convert to moles of O2, and then you can convert to grams of O2. But I'll go ahead and take us through this calculation as well. So, okay, we've got 64 grams of CH4, right? And we multiply it. I'm just going to go through the one line method here. So 64 grams CH4 times 1 mole CH4 per 16 grams of CH4 times 2 moles of O2 per 1 mole CH4 times 32 grams of oxygen divided by 1 mole of oxygen. Okay, so let's cancel out neatly. So the grams of CH4 cancel out, and the moles of CH4 cancel out, then the moles of O2 cancel out, and I've got the unit I want, grams of O2. That's an O. All right, grams of O2. So let's do the math. 64 divided by 16 gives 4. 4 times 2 gives 8. So again, I've got 8 moles of oxygen, just like I had 8 moles of water, which makes sense because the molar ratios between both water and oxygen are 2 to 1 with CH4. So, so oxygen has a 2 to 1 molar ratio with CH4, and then water does as well. So we expected 8 moles of oxygen here. So 8 moles of oxygen times 32 grams. Well, let's do 8 times 3. That's 24. Now that's 8 times 30, actually. So you get 240 plus 8 times 2, which is, 8 times 2, which is 16. So 240 plus 16 equals 256. So we should have 256 grams of oxygen. Okay, double check my math. 8 times 3 is 24, yep. 240, yep. Plus 16, 256, yep. Okay, so that's how many grams of oxygen we should get, or we should need in order to fully combust 64 grams of CH4, okay? So that's how that problem works. And I'll go ahead and erase the board here. And I'll leave you with one last problem. Okay, so what I want you to do is go ahead and give this problem a try. And then this is the last problem with this reaction. So give this problem a try, but pause the board pause the recording when I say so, because I'm going to show you just the answer at this point, just the answer. I'm not actually going to show the entire worked solution. So okay, so you could ask yourself, well, how many grams of CO2 should I get if I start with 64 grams of methane? Okay, so go ahead and pause the recording here and go ahead and try to solve this problem. Okay. So what I want you to do right now is go ahead and discuss with your group, right? See if you can come to um, a consensus on what the correct answer is and why, and go through and really understand why you got to the answer you got and why that's the correct answer. So go ahead and take just a few more minutes to do that if you haven't already. This is a good time to pause the recording. All right. So now I'm going to go ahead and show you the solution, and I'll talk through the work solution, but I'm not going to put the whole thing on the board just so that we'll settle any debates that we may have had. So if you've got 64 grams of methane, then you divide that by the molar mass of methane, 16 grams per mole, to get 4 moles of methane. And then so you know you're going to get 4 moles of CO2. And you can use ptable.com to calculate your molar masses. So 12 for carbon, and you get 2 oxygens at 16 each. So the molar mass of CO2 is 44 grams per mole. So 44 grams per mole times 4 moles, well, that's going to be 160 plus 16, which is going to give you 176 grams. Okay, so you're going to wind up in the end here with 176 grams. 176 grams of CO2. So if you got a different answer, kind of go back and recheck your calculations for both molar mass and then molar ratios. Okay, those are the two likeliest places where you might have made a mistake. But if you got that answer, very good job. Okay, so let's take a look at something new. And so I'm going to erase this reaction, and we're going to take a look at a different reaction. So this reaction is also really important. It turns out that sodium metal reacts with chlorine gas to form sodium chloride, which we need in order to live. Like you can't live with humans couldn't live if they didn't have salt in their diet, table salt. So sodium chloride is a very important chemical for humans. And get this guy drawn a little better. Okay, there we go. And so we have to balance this equation because we see that there are 2 chlorines here, but there are not 2 chlorines on the right side right now. So I'm going to go ahead and put a 2 there, and then I'm going to put another 2 right there. And that's how we balance that chemical equation. So 2 sodiums on the left, 2 chlorines on the left, and then 2 of each on the right as well. So that's a balanced chemical equation. All right, so use ptable.com, and if you do, you'll find out that the atomic mass of sodium is 23 grams per mole, and the atomic mass of a single chlorine atom is 35.5 grams per mole. So what I want you to do is to go ahead and ask yourself this question. If I start with, let's say 46 grams of sodium, how many grams of sodium chloride will I get? So go ahead and do that, and I want you to talk through it as a group. And just like with the last problem, I'm going to go ahead and talk you through the work solution, but I'm not actually going to show it on the board because I want you to have to demonstrate this understanding for one another. Okay, so it's very important that we talk through these problems in a group. If you're really super confused, please reach out to me or to any tutor who might be associated or learning associate who might be associated with our mod. Okay, so I'm going to go ahead and allow you to pause the recording for a little bit while you work through this problem. Okay. So at this point, you're resuming the problem because you've come to a solution and you've talked it through, and you said to each other, okay, so we think the answer is, so let's talk about the answer. So we start with 46 grams of sodium, right? And we know that there are So our first conversion is going to be from grams of sodium to moles of sodium. So we know that there are 23 grams of sodium per mole of sodium. So we've got 2 moles of sodium. And if we look at our chemical equation, we've got 2 moles of sodium for every 2 moles of sodium chloride that are produced. So we've got to end up with 2 moles of sodium chloride at the end. So if you start with 2 moles of sodium, you're going to wind up with 2 moles of sodium chloride. So you're going to have 2 moles of sodium times 2 moles of sodium per 2 moles of sodium chloride, or times 1 mole of sodium per 1 mole of sodium chloride. If you want to get rid of those coefficients, that's fine. And so you're going to ultimately wind up with 2 moles of sodium chloride, and then you're going to multiply the moles of sodium chloride times the molar mass for sodium chloride. So the molar mass for sodium chloride is 23 plus 35.5, which is going to be 58.5. Okay, so 2 times 58.5 is going to give you 117. So you're ultimately going to wind up with 117 grams of sodium chloride. Okay, so 117 grams is what you should get as your answer. 117 grams of sodium chloride. All right, and that should be your answer for that part of the problem. But let's go ahead and take a look at chlorine, right? So like, how many grams of chlorine would we need to react with this many grams of sodium? So let's figure that out. So I'm going to go ahead and erase this, and we're going to start with this many grams of sodium. So I want you to pause, and you can either start from this number, or you can start from this number in order to get this number. And I'm going to let you go through that, but then I am actually going to show the work solution for this because there's a little more context that I want to provide. Okay, so now's a good time to pause the recording, and you can use either value, 46 grams of sodium or 117 grams of sodium chloride, to figure out how many grams of chlorine you would need for this reaction. So go ahead and take a few minutes, pause the recording, and solve this problem together as a group. Okay, so now we've gotten to our solution. I'll go ahead and actually show this entire solution for everybody. So here's how this one works. You start out with 46 grams of sodium, and you multiply by 1 mole of sodium per 23 grams of sodium. Then you multiply by 1 mole of Cl2 per 2 moles of sodium, right? Because you've got 1 Cl2 here and 2 sodiums there. So 1 mole of chlorine per 2 moles of sodium is what we would include there. And then you multiply by, so because the atomic mass of a chlorine atom is 35.5 grams, we multiply that by 2, so we get 71 grams per mole. So you've got 71 grams Cl2 per mole Cl2, okay? So the moles get crossed out, moles of chlorine get crossed out, then the moles of sodium get crossed out, the grams of sodium get crossed out, and we have this situation. So let's do the math. 46 divided by 23 is 2. 2 divided by 2 is 1. So we actually just need 1 mole of chlorine gas, which has a mass of 71 grams. So that's what we're going to wind up with, 71 grams of chlorine gas. Okay, 71 grams of chlorine gas. And because we've calculated mass values for every single component of this chemical reaction, we can actually see something that's really cool. So I'm going to erase the calculation on the bottom. So if I do that, I can actually see that 46 grams of sodium plus 71 grams of Cl2 give me 117 grams of sodium chloride. And that illustrates that during a chemical reaction, mass is conserved. Okay, and that's true. That's true. Mass is neither created nor destroyed during a chemical reaction. So a little shortcut that you could have used, you could have actually subtracted 46 from 117 to get 71, because you've only got 3 chemicals in this reaction. So you could have done that simple subtraction. But it's good also to go through the standard conversion that we just went through, okay? So that's all here. If we understand the material, that's great. If you need additional help, please see me. But now it's time to go ahead and take a look at our mini quiz. Okay, so if you feel like you've got this under control and you understand how all the problems work, go ahead and get started with your mini quiz. You can also submit your notes to Google Classroom. So I'll have the notes link up and I'll have the mini quiz ready to go. And then if you have questions, please reach out to me. Okay, and you can return to the main session, and we'll be hanging out there once all of the breakout groups have gotten started on their mini quizzes. All right, so that's all, and good luck on your mini quiz.